Good day my dear students, welcome back to my channel Otababa Music TV. It's been a long time that I haven't uploaded a new tutorial. So today another topic that I'm going to present to you, and if you are new to my channel, please subscribe before we proceed any further. And don't forget to hit the notification bell so that you will be updated for my next videos. If you like my presentation, please hit the like button. If you have some questions or suggestions, just write down in the comment box below. Are you ready? So my presentation today is about solving equations transformable to quadratic equations. This is under Module 4 of your Self-Learning module in grade 9. Okay, so this time we're going to add or subtract rational algebraic expressions. So this process is called transforming rational algebraic expression to quadratic expression. So our example number 1 is 1 over x plus 2x over 5. Sometimes we encounter algebraic expressions expressed in fractional form, and this algebraic expression is called rational algebraic expression. It is an expression containing a fractional form whose numerator and denominator are polynomials, and if it is equated to 0, if the expression or two or more expressions are separated by equal sign, then it is called equation. So if you find or found an expression separated by an equal sign, then that is called equation. So in that case, that algebraic equation is called rational algebraic equation. Okay, so this time I'm going to teach you how to add or subtract rational algebraic expression. So a rational algebraic expression, as I said, this is an expression containing a fractional form. So the numerator and denominator are polynomials. Okay, so here's our first example. So the first step that you are going to do, you are going to find the least common denominator. So the least common denominator, we find it by multiplying the denominators. So x times 5 is 5x. So our LCD is 5x. So after that, we are going to multiply our LCD to the binomials. So this is what will happen. So we have here 5x times 1 over x plus 2x over 5. Then after that, we apply distributive property of multiplication over addition or subtraction. So we apply distributive property of multiplication over addition or subtraction. So distributive property, or we simply write distributive property of multiplication over addition or subtraction. Alright, so we are going to distribute our least common denominator, so we will multiply 5x to 1 over x. So this will become 5x times 1 over x plus 5x times 2x over 5. Okay, so in this part we can cancel common. So we are going to cancel out x here, and also here is 5. So 5 times 1 becomes 5, plus we canceled out 5 here, so what is left is x times 2x. So the final answer is 2x squared. So we will just arrange our answer into descending order. So from the highest exponent to the constant. So our highest exponent is 2. So this will become 2x squared plus 5. So this is now our quadratic expression. So it is expressed in a simplest form. So as you notice, it is very easy to handle our quadratic expression if it is not in fractional form, unlike in this example. Okay, so again, adding or subtracting rational algebraic expression, or that is transforming a rational algebraic expression to quadratic expression, the first thing that you're going to do is find the LCD. To find the LCD, you multiply the denominators. The product is now already your least common denominator. Then, next is you multiply the LCD to the binomials. So if it is binomials, or you multiply it to the algebraic expression, the whole polynomials. Then you apply distributive property of multiplication over addition or subtraction. Then arrange your final answer. So arrange your final answer in standard form. Okay, so I hope you followed our procedures. Okay, so next example. Okay, so our next example is 4 over x minus 2x minus 1 all over 5. Okay, so again, to read this rational expression, you're going to say all over, because when you just say 2x minus 1 over 5, it means that the over is at 1. So if you say 2x minus 1 all over, meaning the denominator is the denominator of 2x minus 1. So that is all over. If the numerator is more than 1 terms. Okay, so this time we are going to transform this into quadratic expression. So again, our step is find the LCD. To find the LCD, we multiply the denominators. So our denominators are x and 5. So 5 times x, or x times 5, is 5x. Then we are going to multiply our LCD to the binomials. So 5x times 4 over x minus 2x minus 1 all over 5. Then we apply distributive property of multiplication. Okay, so then we are going to multiply, so 5x times 4 over x, or we can cancel x. So we'll cancel x, and then 5 times 4 is 20, minus, we distribute, or we also cancel 5 here, so it becomes 1, and then x times 2x. So this becomes negative 2x. So negative x times 2x is negative 2x squared. And then negative x times negative 1 is positive x. Okay, then we are going to arrange. So express in standard form. Express in standard form. So when you express in standard form, that is arrange the terms or the exponent from highest to the constant. So this will become negative 2x squared plus x plus 20. So this is our quadratic expression. So negative 2x squared plus x plus 20. Okay, so our next example, 2x over 3 plus x plus 1 all over x. So if you have already solved this rational algebraic expression, you just compare your answer if you arrive or if you got the correct answer. Okay, so what is the first step? Yes, you are going to find the LCD. So what is our LCD? Okay, so our LCD is 3x. So we will multiply our LCD. We will just go directly to our solution. So we will do it like this. So 3x times 2x over 3, then plus 3x times x plus 1 all over x. Okay, we distribute directly our LCD. So we multiply our LCD to each of the expression or each of the terms. Then we multiply. So we can cancel 3 and 3. So cancel out 3 and then multiply x times 2x is 2x squared, and then plus, we can also cancel x here, so cancel out x, so becomes 3 times x plus 1. So 3 times x is 3x, and then plus 3 times 1 is 3. Okay. So So as you notice, our answer is already arranged in standard form. So it is already arranged in descending order. So this is now our final answer. Okay, so I hope you followed our process. Then for our last example, 4, number 4. So x plus 1 all over 2x minus x plus 2 all over 3. Okay. So what is now our LCD? So what is our LCD here? So the first term of our binomial rational expression, rational algebraic expression, is also in binomial numerator. The numerators are binomials. Okay, so we multiply 2x and 3 becomes 6x. So our LCD is 6x. So we multiply directly to each of the term. So becomes 6x times x plus 1 all over 2x minus 6x times x plus 2 all over 3. Okay. Then we canceled out, or we divide 6x divided by 2x. So x and x cancelled. 6 divided by 2 is 3. So becomes 3. So we multiply 3x plus, or 3 times x plus 1. So 3 times x is 3x. And then 3 times 1 is 1. And then in this part, we also divide 6x and 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. So it's 1 here. And then we multiply negative 2 times x is negative 2x. So here. Then we multiply negative 2 times positive 2 becomes negative 4. X squared here. Okay, so x, 2x times x is 2x squared. Okay, so we're going to combine like terms. Combine like terms. Combine like terms. So we're going to combine positive 1 and negative 4. So that's become, and we can arrange right away our answer. So we will write negative 2x squared first. So negative 2x squared, and then followed by 3x. So positive 3x. And then positive 1 minus 4 is negative 3. Okay. So this is now our final answer. So it is already written in standard form, arranged in descending order. Okay, so if you have already solved this problem, you just try to compare your answer with our solution. So that's all for today. I hope you followed our step-by-step solution in transforming rational algebraic expression to quadratic expression. Okay, so thank you very much for watching, and once again, this is your teacher, Sir Ababa, saying, in every problem in math, there is always a solution. But before we go further, before we end up this tutorial, please don't forget to subscribe and hit the notification bell so that you will be updated for my next video tutorial. Once again, have a nice day everyone. God bless us all.